Time period of satellite. First one we will discuss about the time period of satellite. Imagine this is the earth surface. Around the earth surface the satellites are revolving. That means this is the radius of the earth and this is the height from the surface of the earth to the satellite position. So what is the time taken to complete the one revolution around the earth? Can we use the formula time taken to complete one revolution around the earth by the satellite? T is equal to 2 pi r divided by orbital velocity. Okay, that means same equation only. Velocity v is equal to distance by time. So time is equal to distance by velocity. Distance is the 2 pi r, the circumference or the distance traveled by the satellite around the earth, divided by the velocity with which the satellite is moving, and that is the orbital velocity. Now, as we already learned about what is the orbital velocity formula, orbital velocity VO is equal to square root of gm divided by r plus h. Substitute the value here in time period. Time period t is equal to 2 pi small r. What is a small r there? So small r is equal to capital letter R plus h. So we can write here 2 pi into small r. Small r means the radius or the distance between earth and the satellite. So distance between earth and satellite means what? We are taking from center of the earth. So 2 pi into r plus h all divided by VO. What is a VO? Square root of gm divided by r plus h. We can rearrange this equation. We can write here 2 pi into r plus h into square root of r plus h divided by gm. R plus h, which is in the outside, you take inside the square root. So we can write here t is equal to 2 pi square root of r plus h the whole cube divided by gm. This is the one of the general equation for time period of the satellite. Now if h is much less than the radius of the earth, if h is much less than the radius of the earth, we can write here t is equal to 2 pi square root of r cube divided by gm, because h is negligible, right? And we already know g is equal to gm divided by r square. So we can substitute here gm is equal to gr square. If you substitute that value, time period t is equal to 2 pi square root of r cube divided by gm. Gm is equal to gr square. R square cancel. So we got the time period t is equal to 2 pi root of r by g. One of the equation for calculating time period of the satellites. Hope it is clear. So same formula, time period is equal to 2 pi square root of r plus h whole cube divided by gm can be used to calculate the height of the satellite. So let's discuss about the height of the satellite. Time period t is equal to 2 pi root of r plus h the whole cube divided by g into m. Gm also can be written as 2 pi root of r plus h the whole cube divided by gr square. So now we can write here time period t is equal to, do one thing, you square on both sides. So left side become t square, right side become 4 pi square r plus h the whole cube divided by gr square. We can avoid the square root there. Now you rearrange this equation. We can write the t square gr square divided by 4 pi square is equal to r plus h the whole cube. So in order to remove the r plus h the whole cube, we can take the cube root. So the equation become r plus h is equal to t square gr square divided by 4 pi square raised to 1 by 3. Therefore, we can calculate the height of the satellite h is equal to cube root of t square gr square divided by 4 pi square minus capital letter R. This is the formula for calculating the height of the satellite. Same way, we can also calculate the angular momentum. Whenever a body is moving in a circular motion, we can say that there is an angular momentum is there. So what is the angular momentum basic formula? Angular momentum is equal to L is equal to mvr. This is the basic formula. In this case, we can substitute here L is equal to mass of the satellite into orbital velocity into small r, whereas we already know small r is equal to r plus h. So we can substitute here L is equal to mvo into r plus h. Substitute the value for vo. What is the orbital velocity formula? M into, come on, what is the orbital velocity formula? Square root of gm divided by r into r plus h. Or we can write the L is equal to m into square root of gm divided by r plus h into r plus h. Take the r plus h inside the square root. So what we can write now? L is equal to, take the m inside, so we can write the gm square into r plus h the whole square divided by r plus h. One r plus h will cancel, so we can write the square root of gm into m square into r plus h. So this is the angular momentum of the satellite's formula. Hope it is clear.